I'm with Beckman Coulter. Let me just start the presentation, and we're going to give you some data in just a moment. I'm going to go through a couple of quick introduction slides to make sure everyone is familiar with our new products, and I'll let Shilpa Parakh continue and give you some of the data from our continued adventures. Lab site, just to be clear, is now Beckman Coulter. That purchase happened this year, and we're looking forward to growing our product lines together. So here is a quick sneak peek of some of the work we've been doing together. Much has been done already this year. This is actually a product that we've provided for some simple drug discovery efforts, but we see our product line with the Echo 525 and the Biomek I-Series instruments really growing in the genomics and NGS space. And so we'd like to really raise the bar on the ultra high throughput and low volume preparations for next generation sequencing. So I'm a little aware that not everyone might be familiar with our products. So Dr. Chow did a great job introducing the Echo. So I'm going to give you just a couple little points here. Again, it's using acoustic droplet ejection in a fully non-contact transfer from our Echo qualified source plates. So anytime you hear lab site, we're going to substitute the word Echo in there from now on. And that's all done with acoustic droplet ejection, which we call ADE. It's a controlled sound frequency and energy. And we vary the energy, but we're getting feedback from the actual sample. And that allows us to adapt to multiple different fluids. One of the frequent questions we get is how does the liquid stay in our inverted plate that's up above our source plate, and that's all done by surface tension, and many microliters can stay in an inverted source plate quite easily. So it's non-contact. We're doing 25 nanoliter droplets in the Echo 525, and that's a consistent drop size because we're controlling that with the frequency and controlling that again with the energy of the transfer. This maintains the sample integrity. We're not applying so much energy that we're sonicating samples. It's actually quite low energy in comparison. But we're getting microliters per second. So with the Echo 525, you can expect 2 to 5 microliters per second from a single well being delivered of your sample or your reagent. And this is really enabling us to change the face of much of the work that we're doing. Reducing the volumes, increasing the speed as we deliver these small volumes and cherry pick samples, for example. And because it's completely non-contact, you're removing and reducing a lot of the possibilities for contamination. The I-Series instruments, the Biomek i5 and i7, are the new Biomek platforms. And these come with greater number of positions on each platform, as well as some other really unique features such as a 360 gripper that's offset so we can do more interactions with devices like the Echo that are just off deck and moving plates around more efficiently. It also has cameras on deck for verification of our samples and setup so that this is all working to reduce a lot of the error and variation in your work. So with that, I'll come back to introducing why these two work together. Again, small volume, rapid transfers, really adjusting to different fluids so we don't have to have a lot of different techniques, and dispense quickly, giving you data because we're listening back with that sound on what did transfer and what was available for the transfer. And that really is, again, complemented very well by the tip-based Biomek I-Series liquid handling, which has the capability of doing the larger volumes very quickly, doing 384 well cleanups as we expand out to this ultra high throughput, doing a whole 384 well plate at one time for those big cleanups. And it's got the 25 deck positions. We saw this as being an optimal pairing of two smaller instruments to give you a walk-away workflow in a small, compact setup with the 25 deck positions to really get all of our plates that we need on the deck, and with a 360 gripper for those interactions and putting the thermocycler on deck and other devices that we might need. So I'm going to back up and let Shilpa continue with some actual data on the system that we've been working on.
Morning, everyone. Thanks for joining bright and early. I am Shilpa Parakh. I am Senior Application Scientist at Beckman Coulter for the Genomics and Automation Biotechnology Business Unit. Going to take you through our attempt of moving into miniaturizing Nextera XT as the pilot project for this integration platforms that Alex talked about. So as we all know and have been hearing, the cost of the project can be significantly brought down by miniaturizing, and this is our effort in contributing towards helping that and increasing the walkaway, increasing the efficiency. So by bringing the Biomek and the Echo together, we are enabling the customers with the solution to keep them budgeted and ahead of their work. And yes, I'm very excited to present this. So in our effort to show this seamless workflow, the Nextera XT was chosen as our first project to be demonstrated. The application is miniaturized by 20x and does sample size from 16 to 384 in increments of 16. Contains all the logical start and stop points for the as recommended by Illumina. We are utilizing active devices in order to have this happen with minimal intervention and maximum walkaway, and to reduce the risk of cross-contamination, it's using filter tips, and for Echo, all the Echo qualified labware. This is the workflow for Nextera XT as handled by both the instrumentation. So it was designed again to keep maximum efficiency. The gray steps are handled by Biomek, the blues are by Echo, and the reds are the manual intervention. The manual intervention currently is for two processes. It's the I5 with the 25 deck positions. So we do need to replenish the deck for quant setup for the QC, and also upstream to swap the Echo inserts. So Echo uses two inserts. One is for the Echo polypropylene plate, and the other is for the Echo low dead volume plate. So once the initial setup is done, the Echo LDV insert and the samples are transferred, the Echo LDV insert is removed out, PP is put in, and then you normalize the samples, and then the tagmentation, the TD and the ATM dispenses are handled by Echo, coming back with the Biomek grippers onto the on-deck thermocycler. And then NT steps are handled by Echo again. The reaction plate comes back to the Biomek deck for, again, the incubation steps. The PCR setup is again handled by Echo, and then the F4 amplification, it comes back on the thermo ATC, and then all the cleanups are handled on Echo. Once the deck is reset, the plan is, so currently the method, and I'll be showing you that in a moment, is already built up till the cleanup part. It's an ongoing project, I'm working on it. So the plan is also to include all the three quant-based protocols. So it'll do the fluorescent based, it'll do the qPCR based, and the MiSeq based plates setups. Once that is done and the plates taken off for the plate reader, the data is going to be plugged back in, and then Echo is going to do the normalization and the pooling. So yeah, according to Illumina, I did some timing comparison for the applications. According to Illumina, the 8 samples, and I'm going to be showing you here the manual, the Biomek alone, and the Biomek Echo integration Nextera XT timings. So according to Illumina, the 8 samples take around 3 hours. This is, we did it early on. It's the Nextera XT done on the i7 hybrid platform, which has the 96 head and the span. And this takes, for 96 samples, around 4.5 hours. And this is for this latest project for the Echo integrated on i5. The 384 samples are taking around 4 hours up till the cleanup process. We are using selective tip pipetting on this project, so it's very dynamic sample number friendly. And both the workflows are available according to the lab's need. So moving on into the actual application. So Beckman has a BSL2 lab, and we do the applications that we make are demonstrated What we mean by that is they are written, they're optimized, tested with actual samples, and then those methods are the demonstrated methods that the customers get. And after we do all that, obviously there's all marketing collateral that's generated around this. So these are ready to implement methods, so customers can get their work resumed in minimal time. So the DMI, or the demonstrated methods interface, are a set of tools that we utilize while writing these applications to provide the ease of use for the operator to run their complex NGS workflows. So the DMI consists of the Biomek method launcher, which also has the deck optics final check, the method option selector, and the guided labware setup. So Biomek method launcher is a software designed specifically keeping end user or operator in mind. The methods are run by the launcher to avoid the risk of accidentally editing these protocols, which the labs already validated and are good to go. Another part of Biomek method launcher is the deck optics final check. So we all know human error happens, part of science. A lot of components that go on the deck, so very easy to make mistakes. Final check helps identifying these common errors and does preventing a failed experiment and the loss of those days. Final check ensures that you placed your labware in the correct location and provides warnings if the labware is missing or there is a wrong tip or plate type present. So as I mentioned, all applications will have a custom HTML-driven user interface. We call it the method option selector. It's based on the application, what does the workflow contain, and so over here, this is the one for the Nextera XT. You can choose the sample number, again, as I mentioned, in increments of 16 for the 384 throughput. The thermocycling can be on deck or off deck, methods built to handle both. And then the different workflows are modularized, so you can select each and all as per the day's requirement. This is a deck layout with a full 384 samples, how it's going to look like. So left is the echo. The deck does contain active devices, so there's an orbital, there's a static belt to keep the stock reagents cool, and the thermocycler from Thermo, the ATC, and a wash station. As you can see here, tip boxes are staggered. This is to handle all the selective tip pipetting. This is what enables us to do that dynamic sample number handling. So the reagent aliquoting is done on Biomek, and then all the transfer steps are done by the echo. So the echo polypro plate is also aliquoted and is the echo source plate. So it's the Biomek aliquots the reagents in those plates, and then it's taken to the echo for all the transfers into the destination plate. The good part again about that plate is we're only using few columns per 384 experiment, so you can freeze it, you can reuse it. So guided labware setup is the last component in the method interface tools, and again it helps set the deck correctly. So we build it up again application to application basis. It provides detailed instructions for the type of labware and where it goes on the deck, and each reagent position and the volumes based on the sample number and the part of the modular workflow that is chosen. So on the left, you do see a chilled, the cold block, which keeps the stock reagents, so kind of details it out, what it contains, how much volume. And on the right is a modular reservoir, the 12 column, which is handling most of the bulk volume. Here is the little video of the actual deck. So the source insert is coming out. This is the 360-degree rotating gripper that's going to be putting the lids away as needed. So all the plates are covered to prevent evaporation. And the plate's going to be picked up using the wide grip. So the gripper can do narrow and wide grip. It's putting the source. This is the sample plate. That's the LDV plate that's going into the echo. What it's lifting right now is a P+ lid for all the thermocycling incubations. It's Basically a metal with a padding underneath, and when the plate sits on the ATC, the lid closes and presses it down, thus preventing any cross-contamination or evaporation. So for the reaction plate, that lid will be used all throughout the method. So now plates, all the reagents were aliquoted, as I mentioned, by the Biomek and lidded. So that goes now dispensing the sample, and this setup is allowing us for maximum walkaway. After the reaction is complete, it is going to bring it back on the deck. Moving on to the actual experiment. So the project, as I mentioned, is still in development. This is the first 384 sample experiment data that I'm showing. The method's optimized, and I'm conducting more experiments with different sample types. Unfortunately, here I only have the QC data. I don't have any sequencing data. Didn't have time for that. So 3 strains were chosen, the Bacillus cereus, the E. coli, and the Rhodobacter spheroids, and the workflow was designed as it shows on the right, different columns getting the 3 strains. Reaction times were miniaturized up to 20x, and input sample was 50 picogram. Cleanup was done in the 384 well plate with a final elution volume of 12 microliters, and it was analyzed on the tape station with the D5000 tape, high sense, and quantified with qubit. These are some of the tape station traces. The yields were all between 10 and 14 nanogram. And this is a overlap trace. So to summarize, again, as you know, we all talked about the cost, the productivity, and the quality all see a positive impact. Miniaturization has been demonstrated to work up to 20x, thus reducing the cost per sample drastically. The increased throughput with improved turnaround time and reduced hands-on time. Demonstrated methods interface tool provides the additional buffer that's needed to reduce the setup errors. Demonstrated methods will reduce time to implement in the lab. With automation, the cross-contamination can be reduced and helps in accurate and precise sample transfers, and of course, the pre- and post-dispense reports. I'd like to acknowledge all my colleagues in the marketing and applications team and the integrated solutions team that helped this make possible. We do have the integration in our booth currently, so feel free to come by, say hello. That's again the Echo and the Biomek i5. That's the end of my presentation. Thank you.